Am I audible?
Yes, ma'am.
Okay, fine. Okay, so I'll just start the session. Give me 1 minute. Let me know if the screen is visible to you. Yes, it's visible.
Yes.
Okay, give me 1 minute. I'll be back. Sorry for the delay. Um, so today I have to conclude the session by 9 p.m. Okay, so I'm going to wind it up around 8:55, and I'll be giving you about 5 minutes if you have any queries or anything. Okay. So before that, as I already discussed you, today I'm going to give you some overview about the different types of the models and quick idea about how the different services work in the AI. Okay. So we already discussed about what is AI, what is ML, what is DL, okay, deep learning and all. So here today I'm going to give you about the a few context about the different services that we can see. So one of the service that we can see is the computer vision. So what do you know by computer vision service? Like whenever we have any kind of a pictures, okay, it's kind of a video or it is kind of a images when we are having. So we will be using this kind of a visual things as an input, and we are going to get the prediction or the outcome in the form of our expectations. Like the outcome we are expecting either might be what exactly present in this video, and it might be read the text that is called as the optical character recognition and identify the people in that particular picture that we are going to give. Like that, we our prediction should be different, okay, but the core concept is we are going to give the visual things as the input. So we are expecting the outcome in the form of a different format. Okay. So here, so when we see in the first image, we are having an image classification. Okay. So as part of this image classification, the taxi is the, in the image we can see the taxi. Okay. It's identifying the object. Okay. In this particular image. And we have a optical character recognition, OCR. It is identifying the text in this particular image. And object detection, like example, if I provide the multiple objects, okay, we wanted to discuss what are the different objects present in that particular uh, image. And so we have a semantic segmentation. Basically, when we say semantic segmentation, when we have different types of the object, it will try to mask the different types of the objects with the different colors. Then for end users, it is easy to identify it. Then I analyze the image. Okay. So when we say image analysis, it has to give the brief overview about what exactly happening in that particular image. Like example, so I can see here it is analyzing as a person with a dog on a street. Okay. Means it's doing the image analysis and the face detection analysis and recognition. Here, whenever we basically we will be having a knowledge base. In that knowledge base we are going to store the multiple users images and all. Okay, we are going to identify, sorry, how many oh, is my face is whatever the face image I am providing, whether it is matching with the present image or not, in any persons or not. And facial features changes also. Okay, so there is a different types of a services we'll be getting in this face detection. Accordingly we are going to analyze it. Okay, then we have a Azure one. Okay, computer vision service. So in the Microsoft Azure we can use the Azure AI Vision, okay, or the Azure Vision Studio. This is the kind of a Vision Studio is a kind of a new window where exactly we can see all the vision related services. Okay, so like quickly I'll just show you, okay, how it is going to work. You can see it creates services in different ways. Okay, Azure AI services. Okay, this is like kind of a AI services. When we say Azure AI services, it's kind of an umbrella service where exactly we can create different types of the services. Okay, I'll just show you by creating this so you will get an understanding. So I'll go with the region as a east west only. I'll create as a Azure resources overview. And this is the pricing tier. Okay. I have to click the checkbox to understand all the terms. I'll quickly go to the review and I'll create a service. Okay, so I'll just show you what are the different types of the services that we can create it under the Azure Vision. Then, okay, I'll explain you about this image, okay, quite later. Now, NLP. So, what is NLP? Anyone had idea why where exactly NLP services are used? We already discussed. What is NLP?
No idea.
No idea. Were all
Mm,
present in the previous sessions. It's a natural language processing. Basically, whenever we wanted to do any kind of a language related services, kind of a translations, if I wanted to do, like kind of a speech to text, text to speech, okay, one language into another language conversion when we wanted to do. So at that time, in the whatever the services that we'll be using in the backend, NLP is the present. Like example, so you might have seen like a Siri, right? So how exactly it will understand your instructions, because in the back end NLP is used which can understand your commands and accordingly take an action. Means basically what exactly this NLP services when we'll be using, it will help us to analyze and interpret the text in our documents, email messages, and other resources. And it will interpret the spoken language and synthesize the speech responses. Like example, if I have any kind of a speech, spoken language is present, okay, I can try to analyze on that. Automatic, it will even help in the translation, okay, and it will interpret the commands and determine the appropriate actions also. Okay, these are the actions it is going to do. Give me 1 minute. Okay, so if you can see the few examples of the NLP, so we have a language translator like a Google Translate, and then the search engine also. Like example, we have a autocomplete in the Chrome. Okay, so I mean Google Chrome, when we ask, like we if we provide some text, okay, if I wanted to, it will give you a auto completed sentence. Like if you are asking, like kind of, I want certain information about the diabetes. When you say it's give with examples like that, it will try to auto complete it and give you the sentence. So that is see, these are all like smart assistant like Siri or Alexa, customer services, email filters, okay, survey analytics, chatbots, social media monitoring, and see if in the chatbot services, NLP is also one of the base service because it has to interpret the services. And then the text analytics and predictive text, okay, like Grammarly. So these are all the applications of the NLP, like where exactly currently we can see the NLP application. So going further, so when we will be having some business scenarios, okay, like example in the testing, I wanted to um, design some of the tool which is going to predict and give me the outcome. So at that time we can try to utilize these services, okay. Then we have a document intelligence. So right, previously we had a knowledge mining also. Like see, these two things, when we say document intelligence and knowledge mining, see, it's kind of a data analysis. When we have a huge documentation, like if I wanted to interpret that data, like example, when we have a small images, so at that time, like a kind of a pictures, like example, I have a captured pictures and all, so I wanted to analyze that images, then we'll be using the computer vision services. Like, and if I'll be having a huge documents, I wanted to extract certain data from that, or if I have a huge document, I wanted to predict and make a summary. Like it's, see how the this document intelligence services work is, so you have a complete book, okay, you wanted to submit that PDF, and you wanted to get the summary of that particular book. How do you get it? So here we can use the document intelligence services, so at that time it can summarize and it can give you the outcome. And even when I wanted to highlight certain keywords, so at that time this service is going to help us. So then Gen AI, okay. So then Gen AI, when we say, typically, okay, it is going to understand the natural language input which you are providing. Sometimes even the kind of it can accept the input, depends on the model to model. Few accepts only the text format, few accept the images also. And by analyzing your context, what you are submitting, it will try to interpret it, and then it is going to give you the appropriate response as based on your input. So here, that's where we call it as a prompts. So your prompts are going to play a major role in getting the outcome. So the input format always in the form of text or the images. Some models even accept the video also, and output format will be either in the form of a text, image, or the audio. The form which you are submitting, you can expect the same thing in as an output as well. Okay. So in the from the Microsoft, if we wanted to use the Gen AI models, like we can use the Azure OpenAI service. OpenAI service we can even get as an individual service also. Okay, or we will be getting from the Azure also. Okay, I'll be showing you how exactly it's going to work is. See, if it is in the Azure, when we say, you can see, right, I created one Azure AI service multi-services account. See, when we say multi-services account means if you create this Azure AI services, right, from this you can create multiple services. Means we can create a kind of a decision services, language services, speech services, vision services, document intelligence, and metrics advisors. These are the multiple services we can create together. Basically, see, they have did it for the billing purpose. Okay, you don't need to worry much about that. You have to understand internally how the service is going to work. Okay, and after that, uh, like as I was talking about the OpenAI. Okay, see, OpenAI, when we get when we wanted to talk, this is one of the Gen AI model which is being provided from the Microsoft only. Okay, if you wanted to get the subscriptions of the OpenAI and if you wanted to start on your own, okay, so there is a site where exactly you can try to go and get the subscription of the OpenAI. Okay, let me find that. Okay, see here we can log in and we can try to get the subscription of this particular OpenAI as well as an individual service. Okay, if I wanted to get it with the Azure, okay, so then we can go here and we can try to create my own service also. Okay, so that's where I want to talk about. Give me 1 minute. Okay, this is what it will represents the difference. Okay, so yeah. So there is a difference between the private and the public cloud models. Okay. So what is mean by private and the public cloud? Anyone know the difference? Anyone
Um,
know the difference of the public and the private cloud?
no, ma'am.
Okay, fine. See, when we say the private cloud, it's like we will be having our own servers. Okay, organizations will be having maintaining our own servers, and we can try to deploy. See, we can try to take a subscriptions of the OpenAI, and we can configure that software. We can try to deploy it. Okay, so here what is, we will be having some advantages and disadvantages also. What is that advantages means, as the environment is private computing resources we'll be having, like we no need to merge with the other organizations, because when we say the public cloud, it's like they have the public server wherein multiple organizations come and deploy their own application. Okay, uh, so in that way, in the same region, in the same server, multiple organizations will be running their applications. So this is kind of a environmental changes. So here, when I have my own server, if I am having my own private cloud, I can deploy only my own server. See, this is like a private cloud also comes. It's like we are having private, without cloud also we can have our own server setup also. Okay, and when we say about the auto scaling, basically in the private cloud, when we are saying, usually the expenses are very high as we are having our own dedicated one. And if I wanted to scale up, what is meant by scale up? Kind of, if you wanted to increase the computation size of servers, okay, like compute capacity of your server, it will be very easy to do it in a public cloud. But in the private cloud, we will be not having much access to increase that scalability. And when we say about the security, basically which one will be the good security, which one can provide the high security?
Private one.
Private.
Hmm?
Private
So
one.
private is
Private.
going to give you the high severity, okay, high security. Why? Because we are having only our own server. Okay, here we are just having a multiple servers together. Okay, and reliability. Okay, like means how flexible your server is. Okay, so it's a high servers are either on the site or hosted by the provider. Okay, means example, I can have a kind of our own server also, or I can host it on a cloud platform also. Usually the reliability is medium here, depending on the internet connection and the availability of the provider. Basically, like it's the example, I'm going to get the AWS cloud or the Azure cloud. So at that time, when compared to the private cloud, so it is going to have a less reliability. And cost wise also, when you say the cost, which one is the highest one? Which one cost more?
Private.
Private.
Definitely. See, it's like we are going to have our own server, right? So it's going to cost very high. So when we say the public one, it's kind of a every multiple organizations using the same platform. So the kind of the cost will be low only. Then we have a function and a expandability. Okay. So full range of functions and great scope for a customizations will be there because we'll be doing on our own. But here, based on the standards process, because see, when we are using the public cloud platform, so certain rules and all, we have to rely on that cloud providers. Okay. There is a service level agreement which they are going to use. Okay. We have to stick for that. Okay. There are certain restrictions and the usually restrictions and limitations on the resource utilizations and all, so we have to obey for that. Okay, there are certain conditions which we have to follow for it also. See, this is about the different public and private cloud like that. Okay, and so as I told, it's like when I want the open AI, it's like, see, it's not in the cloud platform. I can go and I can purchase its subscription. I can have my code base. I can use this OpenAI API and I can deploy that services which I am creating on the my own private servers. Okay, that is how when we purchase this OpenAI subscription, it is going to work. But I don't want to work on my private. I wanted to go ahead and work on the public. So at that time, what I can do is, so in this particular Azure only, there is a service called Azure Foundry. Okay, I can create that service and I can try to deploy it. You got some idea? You got some idea about the public cloud and the private cloud?
Yeah.
Yes, ma'am.
Right. Now, so challenges and risks. Okay, means see, when we take AI, definitely we'll be having a lot of challenges. Okay, so it's like we have to make sure that it's not going to harm anyone. Okay, these are some of the challenges, like bias can affect results. A loan approval model discriminates by gender due to bias in data with which it was trained. Basically it trained that you can give more faster to the men, you can give slower to the women, like that. See, we had not given any instructions only, but by default it is taking a different instructions. So at that time it's a bias. Okay, so what exactly we can do, we could, it is not able to handle that scenario. Okay, that's a kind of a discrimination, and errors may cause harm also certain times. So kind of when we say automatic automatic car when we build, so it even when it is driving it may cause an harm. Okay, and data could be exposed, like certain times when we are having a certain data management, it might be easily accessible. Sensitive patients information can be easily accessible by using the certain AI tools. See, these are some of the potential risk that we are going to handle. We have to handle with the AI. Similar kind of a risk when we are working on the AI. So how we can handle it? To handle it, we are going to come up with the principles called responsible AI principles. Means basically if you go to the any platform, whenever you are designing the AI tools, it might be AI agents, it might be any kind of a AI tools if you are developing, you must have to follow certain principles. Okay, that principles are called as the responsible AI principles. So examples in when we take fairness. Okay, so what is meant by fairness in general? See, if this system is working fairly means what are the things it is obeying? So what are the things it is obeying? So basically whenever we have certain rules, okay, at that time it's not going to kind of whenever we build like let's assume we'll take an example of a machine learning. Okay, whenever I am building a machine learning model, so it is going to like which is going to handle the loan approval. Means when I provide certain data, what exactly it should do is it has to predict whether that person is approve eligible for the loan or not. Okay, at that time it can we have to make sure it should not discriminate the loan approval or the loan prediction based on the gender, a person's ethnicity, and some other factors. Okay, like example, his caste. Okay, and is kind of studied college. Like there are certain things which we are going to train that model. So when we provide the details, it should not discriminate, or it should basically, when we say the loan eligibility, there is a factors to predict. Like example, how much salary that person is getting, and like kind of what are the previous loans he is having. Okay, and where exactly he's working, and his historic loan clearances history. There are only few specific factors on which we are going to judge it. Okay, only it should take the prediction according to that factors. Apart from that, it should not predict based on the gender. Means how we have to make sure is when we are training a model, we have to check, okay, whether these are the features which we are considering that to predict or not, and we have to remove that features when we are training a model from the prediction. Okay, is it clear?
Yes.
I want you to interact. Let's make interactive sessions rather than one person speaking, others listening. Okay. If you have any queries, also we
Yes,
can parallelly
exactly.
discuss. Yeah. So then we have a reliability and a safety. Okay. So see, when we just build an AI tool, it's our responsibility to make sure that it is very safe. Okay. And it can be used more reliably. So at that time, like let's assume we had built certain kind of a AI based tool which can a machine learning model so that diagnose the patient's symptoms and recommends a prescription. Okay, so in this case it's very sensitive, right? Because if it's able to make 1% like kind of a 10% small wrong prediction for one person, like example, if it is going to treat 100 people, even if one person it failed to predict a valid description and it is going to give a invalid description, what it is going to cause? One person's life, right? Hmm? Isn't it? So in that case, okay, when we will be working on this kind of a models which can keep a human life on risk, so we have to test very rigorously, and we have to make sure that it's not going to have anywhere a wrong prediction. So once we are confirmed safety, then only we are authorized to move that into the deployment. Then the privacy and the security. Okay, so when we say the privacy and the security, the models which we had been designed, so that should be more secure and it should able to maintain the security, I mean privacy also. So what is meant by, okay, there is a another term here, the transparency. So when we say the transparency and the privacy and security, both are different terminologies. Okay. Like example, I had gathered certain data, like kind of a user's information. Okay. So when I gathered a information, like I am doing it within my organization, I am developing certain model. So for that reason, I had used a person's name, their bank account, and their historic some transactions details and all. So once the model is designed, okay, when external person accessing, it's expected to give the prediction. Okay. Instead of that, if that model is going to leave this information also, like bank accounts and all, so it's going to cause a huge depth to that particular process. Like they can even kind of a do certain, they can use that particular data in a different manner. So that is going to harm the privacy of that particular person. Okay, and even at the organization level also, when you are trying to store the data, if it's going to leak the data, it's going to cause a huge harm to the organization. It may leak a sensitive information. That is different. Or what is meant by transparency here? Transparency means, see, it's like whenever it is taking a decisions, okay, so at that time it should take fairly, okay, and also it should, if a person is not satisfied, okay, with the response, it should able to give the explanation or the why exactly that decision has been taken. In that case, if it is valid, okay, kind of, it can give you the feedback on its decision, so that end user can understand how transparent that AI is. Okay, that is what it means. Like example, it has given a prescription. Okay, it should be transparent in giving like why exactly that prescription has been given like that. Okay, then the accountability. So when we say the accountability, so nowadays you might have seen there are a lot of people working on the AI rigorously. And so in that case, whenever the AI tools had been built, okay, and so if it start working on the real time, we have to make sure that that particular AI applications which has been built, they are like ethical and legal to use. Okay, they met all that particular standards. Okay, so for that reason, there should be a one person who is going to take the accountability of that. Like example, as a developer, I am going to take a accountability for launching that AI application, wherein it's not going to create any kind of a unethical issues. Okay, like that. Fine. See, this is like some basics about like why we have to follow the responsible AI principles. Well, see, there are, when we are developing a different AI tool, so different types of the rules that we have to follow. So once we kickstart, like we'll start going into a different AI principles, and we'll see how where exactly we can add and everything. Okay. Then so here I'm going to give you about, as I already told, like we discussed about the machine learning yesterday. So we'll just talk about like how this machine learning works. Okay. So we know there are like like example, we'll be having a on and high level 4 different stages. Like, so we are going to do the data gathering, data cleaning, and then the model selection and the training of the model. After that, we are going to do the fine tuning if we required, and we are going to do the testing and evaluations before fine tuning. After that, if it is required, we are going to do the parameter tuning. Then we are going to deploy that into the production, and then we'll be monitoring that particular model that we had been designed. Okay, so before we'll see that how it's going to work, we'll try to understand what are the different types of the machine learnings. Okay, so in the machine learning, basically we are having a 2 different types of the models basically. So supervised machine learning and unsupervised machine learning. In the supervised machine learning, we have regression, classification, and in the classification we have 2 types: binary classification and multi-class classification, and we have a clustering also. Okay, so we'll try to understand what is these models. Okay, why exactly we can try to, where exactly, means how, when exactly this particular algorithms can be applied with that particular model. Okay, so yeah, let's get into it. So first one is the supervised learning model. Okay, so what is this supervised learning model means? Basically, here we are going to make a predictions or the decisions based on the label training data. Okay, means whatever the training data we'll be having, so that is labeled, and on that particular label data, we are going to take a prediction. What is meant by labeling? Yeah. So here, uh, like basically, when we are taking certain data, we are going to have the feature value and the label value. Okay. So basically, these particular, whichever the data that we are using, okay, is used to train our models by determining the relationship between the features and the labels in the past observation, so that now labels can be predicted for a feature in the future classes. See, basically what is meant here, the label is, you're going to have a name for the particular data that you are going to submit. Basically, you can consider as a fields which are present. Okay. Uh, so each column name will be having a specific name. Here you can see. Okay. So here in this particular image, where exactly we are using, see, we have a particular data. What is this data? Like you're going to see, give multiple records. Okay. If you are going to give this particular data, it has to predict. See, if you, by seeing this, what I can understand is there are multiple images which are there. Okay. That images are labeled. Labeled means each image has a name. So when I provide this, it can identify it as a carrot. Means its backend, it is given a name. It is also a carrot for this tomato like that. So I'm going to create a model which can give me the outcome, means segregation of the each different types of the vegetable. Okay. So basically, if I am giving this test data, like I'm going to give the test data in the image format, the output it can label it and give me the image. So here, because in the backend we saved these labels. Because of that, it's going to identify by mapping this image, it can give us the label as an outcome. Is it clear?
Yeah.
Yeah. Okay. So here the data set includes input and output pairs. Okay. Where the outputs are the correct answers are the categories for the input that we are going to give it. Okay. Yeah. Let me go back to this. Basically, it's like what exactly we are comparing, which data we are comparing. Okay. See, first we'll try to discuss about the types of the models as supervised machine learning and unsupervised machine learning. So first, regression model. See, what is meant by regression is whenever we are going to predict the model, if the outcome is in the form of a numeric value, that is called as the supervised kind of a supervised machine learning. In that, it's a regression model. Means, like example, I wanted to predict the kind of a temperature tomorrow. So temperature you will get it in a numeric form, right? Isn't it?
Yes.
Yeah. So in the same way, I wanted to kind of I'm going to sell a particular fruits today, and I wanted to predict how much uh, money I can get today. So this is also like example, the money I'm going to give it in a numeric format. Okay. And I wanted to check the fuel efficiency of a car based on its different size, like weight and all. So at that time also the prediction will be the efficiency means a percentage. Okay. So like that, whenever I am expecting the outcome in the form of a numbers, at that time I can say this as a regression model. Okay. From the testing perspective, can you give me some examples when you can apply the regression model? Let's assume you are going to build a AI machine learning model. So at that time, when exactly you can apply the regression model?
When there is a repetitive task which we are performing, we'll
Mm,
apply regression.
mm, mm. Like example, you can build a defect prediction model, right?
House price.
See, house price prediction, this is a generic one. Like example, you're going to give a different parameters like in each area that house is there, what is the brand, okay, what are the facilities that you're going to get, what are the materials that you're going to they are used, is the house is new or old, like that. You're going to give certain parameters, based on that you wanted to predict the outcome. Okay, approximate cost of that particular house that you wanted to purchase. This is like a generic one. In the testing perspective, like example, I wanted to predict the number of defects in the particular release I am going with. Okay. So at that time, I can take this as a parameter, like I can define the training data set and commit id. Like example, these are the kind of a different parameters that I can use. This is called as a labeling data. Okay. Commit id I can take, branch commit id. So developer name who has worked, basically when the developer is working since 3 years on that particular module, at that time chances of the defects are less. If a new joiner is there, then the chances are more. And when we provide the commit ID, it can understand how complex is the changes. If there is any multiple files has been updated the change, then the kind of more issues that we'll be getting it. Then the module, okay, and the lines of the code changed also. Time span last commit it happened. Branch type which they had created. Usually branch type might be not having any impact. Merged without review. See, this is going to have a multiple bugs. Okay, so like that, we are going to give the different labeling data, and later we are going to understand the relationship between the each data which is going to affect and all. Then we can train a model. Okay, so when we are training a model, okay, so that we can try to use, see, as the prediction is number of defects, right? So at that time we can use the regression model. In the regression model also we'll be having a different types. Okay, like we'll be having a random forest, xh boost, and Poisson regression. So these are some of the regression models which we can get an output in the form of a numeric value. Is it clear?
Yeah.
In the same way, can you think and let me know, like if I give you a chance, okay, to work on the testing one, so where you have to apply, I mean, kind of a testing concepts, okay, where you have to apply the knowledge, uh, means you have to use the regression model. What exactly, which scenario you can take it? Hmm?
Could you please repeat the question, ma'am?
Sorry.
Could you please repeat the question, ma'am?
See, we had taken a for a regression model, we had taken one example as a defect prediction model. Okay. In the similar way, can you think and let me know one more model that you can build, or one more business scenario that you can take to work on the regression model? Anyone can try?
Weather prediction.
That is a generic one. I'm asking from the testing perspective. You can take any automation or functional testing, API testing, DB testing, anything,
I mean,
or the
performance testing.
process. Yeah, anything you can take. But you have to tell me where exactly you can apply this knowledge. You take a time and tell me by the end of the session, okay?
Number of test cases written.
Yeah. So how you are going to exactly, this is one of the scenario. Like, see, you wanted to predict based on the kind of per day or in 1 month, a team, how many test cases it has built. So if you wanted to predict that, or means in a month how much it can write, how many test cases the team can cover, if you wanted to predict that, so what exactly we can do, we can have the type of a number of test engineers involved, and expertise of the test engineers, and time duration that they are going to take, and the complexity of the model, okay, and type of a testings that we have to cover. Like this we can take multiple parameters. By taking these parameters, when we train a model, so our model can predict the appropriate number of test cases that team can cover in a given period. Correct? You're
Right.
getting? Yeah. So then the classification model. So when we say classification model, see, this is a kind of a one of the supervised model only. Okay. But here we'll be taking the labels represents the categorization or a class. Okay. Basically here we have a two scenarios. One is binary classification, another one is the multi-class classification. When we say the binary classification, so here the label determines whether the observed items is, basically here when we say the outcome should be in the form of true or false, positive or negative. Okay, so that is what how the prediction is. See, in the regression it's a numeric value. So when you say take the binary classification, your outcome should be in the form of true or false or positive or negative. So here are some of the examples. Okay, you have to predict whether the patient is at the risk of diabetes or not. Or you have to just check a bank customer will default get a loan based on his income or not. Okay. So here another example is mailing list customer will respond positively to a marketing offer based on demographic attributes. And okay. So you can ignore this. Okay. We can discuss from the testing perspective more scenarios. Okay. Let us come back here. So here one of the example is for this classification, binary classification model we discussed. Okay. So here defect classification prediction. Okay. Give me 1 minute. So one of the example we can take is automation example, defect classification prediction. Like we have a training data set, okay, wherein we have a failure ID, exception type, failed step, okay, browser console error, parallel execution, invalid test data, test past failure, and defect classification. So it's like it can do the defect classification prediction, okay, which type, okay, it is. Like example, when the automation scripts are getting executed, basically whenever the test case fails, okay, the test execution fails, I wanted to use this tool which can predict whether it is failed because of the automation or it's because of the defect. Correct? Is it a valid scenario or not?
Yes,
Yes, it
ma'am.
is.
Yes. So that for that, if I give the failure ID, what exception it because of what exception it failed, okay, and what step it failed, and if I take the console error, and also whether we are using a parallel execution or not, okay, because when we do the parallel execution there might be chances like because of the sync also, and whether it might be because of the invalid test data or not, okay, and similarly past whether we found the same kind of a failures or not. So when we are comparing with this data, we can get the outcome in the form of a whether it's failed because of the bug or because of the automation script issue. Okay, so we can use here the uh, for the model training we are going to use the classification process. Okay, and so after that we can try to our model can try to predict the outcome. Okay, so it's like basically sometimes it might be because of the timeout or locator. At that time it can predict if the issue is not because of the defect, so timeout or the locator issue, or sometimes it may give me the outcome as a wait time. When it is because of the defects it can give me the outcome as, see, it's like in the if it's not a binary classification, okay, at that time it can give the outcome. But if I'm just wanted to predict it's a defect or not, at that time it can say if it's a defect, it will say yes. If not, no. Okay. Is it clear? Can you think one scenario for this binary classification in the testing itself where you can apply this knowledge?
When a login fails,
Hmm?
scenario where when a login fails and it's defect that login didn't get through, a user could not
Okay.
log on.
I didn't get you.
So defect can be anything. I was thinking
Hmm.
more on terms of when a user cannot log on, like when I'm trying 100 user logins and one of them fails. So is it a defect or is it because of the
Hmm.
system or the environment?
That is the one we are already covering here, right?
Okay, okay.
Okay. Any other way? So fine. You can think of and we can discuss from here tomorrow. What I have done is in the same chart, I had given you some of the quiz forms. Okay. So you can try to take out that quiz forms and you can try to fill it up. So we'll be having a 10 minutes. Okay. So you can try to submit that quiz form and then you can draw. Because once you submit the quiz forms, you will be seeing the how much you got correct also. Okay. So if you want, if you have any queries further, so we can discuss tomorrow. Is it clear? I'm stopping here. Like we'll continue from binary classification model only. We'll discuss few more examples. Okay, and we'll continue tomorrow's session. So today I'm winding it up, and I'm giving you the forms to fill it out. Like till now, whatever we learned, like AI, ML, DL fundamentals, and difference between the AI testing and the ML testing, normal testing, software testing, and also model differences. Okay, you can skip the even third one. Okay, sorry, second one, types of models, still because we are discussing. And if you're already good with that, you can start trying to take up that. It's kind of a quiz. Okay, then AI challenges and responsible AI principles. These are things we already covered, so you can try to take it up. So anyone has any other queries? You can copy into your, if you're going to miss this chart, so you can copy into your system. Fine. So can we drop? So once you submit, you can just post it in a group, respective group. Is it good?
Yeah, thank you.
Yes, ma'am.
Yeah, fine. Thank you, everyone. Yeah, we'll connect back tomorrow.
Thank you.
Thank you, everyone.